In this concept, we will explain the technologies of massive MIMO and the beamforming, and explain why they are one of the critical physical layer technologies in the new radio. So actually the massive MIMO, or multi-input, multi-output, and the beamforming are playing an important role in improving the capacity and the coverage and the spectrum efficiency of the network, and hence it is playing an important role to improve the user experience. As we know, the high frequency means that the size of the single antenna will be very small, and the area for receiving the energy will also be very small. And to overcome this small area on receiver side at high frequency, we need to use a large number of transmission antennas, which is the massive MIMO. Also, one of the drawbacks of the millimeter wave is that the signals are easily blocked by objects, and they tend to be weakened over long distance. So the massive MIMO and the beamforming can help by focusing the signal in a concentrated beam that points only in the direction of the user, rather than broadcasting in many directions at once. So let's start with the massive MIMO. So the massive MIMO, or massive multi-input, multi-output, means that we are using multiple antennas on both transmitter and receiver side, which is helping to concentrate the signal and to suppress the inter-cell interference. Release 15 new radio introduced a scalable and a very flexible MIMO framework that has been enhanced further in release 16. The massive MIMO framework supports MIMO across the sub-frequencies of 6 GHz and also across the millimeter wave frequencies, with many antenna elements and different transceiver architecture supporting the digital, the hybrid, and the analog transceivers. So in practice, massive means there are 32 or more logical antenna ports in the base station. So if you are using more than 32 antenna ports, this means that you are using massive antenna or massive MIMO concept. And the common 5G massive MIMO antennas used are 64, 96, 128, and even we have also 256 antenna systems. Now we need to understand the concept of beamforming. So to understand the concept of beamforming, let's look at the figure on this slide. There are two antenna system cases, and let's assume that the two antennas are transmitting exactly the same amount of total energy. So in case 1, on the left side, the antenna system is radiating the same amount of energy in all directions. So the 3 user equipments around the antenna would receive almost the same amount of energy, but of course large portion of the energy is not directed to the user equipment or the 3 user equipments. So a large amount of the energy is wasted and not directed to the user equipment. In the second case, which is on the right, the signal strength of the radiation pattern, which is called like a beam or in the shape of beam, is specially formed in a way that is radiated the energy in direction of the user equipments only. So in the direction of user equipments, much stronger energy beam is focused and directed to the user than the other parts which is not directed to the user equipment. So from this you can see that the beamforming is helping to focus the signal in a concentrated beam that points only in the direction of the user rather than broadcasting the energy in many directions, which is wasted at the end of the day. And also, as we discussed, one of the drawbacks of installing so many antennas with the concept of massive MIMO is that it can cause more interference also, And that's why the 5G stations must use the concept of beamforming to concentrate the signal which is reaching the user equipment. So in conclusion, we can say that the beamforming is a technique that focuses the wireless signal towards a specific receiving device rather than having the signal spread in all directions from a broadcast antenna as it normally would be. And that will result in more direct connection, which is faster and more reliable than it would be without using the beamforming. And the idea of beamforming seems for me that it helped to reduce the interference while transmitting from many antennas at the same time because of the signal processing algorithms, which are plotting the best transmission route through the air to each user. And the result is that by using this approach of beamforming, this will strengthen the signal chance of arriving to the destination, and it will reduce the interference for everyone else, and also it will enable the 5G millimeter waves network to deliver high capacity and high efficiency. So in conclusion, for the massive MIMO and the beamforming, the massive MIMO can improve both coverage and capacity, and it is a key technical solution for 5G networks. But of course, you should also know that the deployment of massive MIMO will require three considerations, which is including the performance requirements, installation requirements, and of course, always we have the cost consideration. On the other side, the technique used for beamforming will help to perform beamforming, beam steering, and beam tracking techniques that will enable to concentrate the signal reaching to the end user or the user equipment. You can see in this picture that also using more dimensional beamforming techniques will add more benefits. So for example, the 2D beamforming will provide more benefits compared to 1D beamforming. And therefore, 64 transceiver or 32 transceiver may have performance advantage compared to 16 transceiver. So at the end, you need to know that the massive MIMO and the beamforming are major concepts for 5G new radio, which are mainly enabling the use of millimeter frequency bands in the 5G, and it is also enabling the operator to make revenues from using the use cases of 5G. And by ending this section, we can say that we have, and here a list of the references that you can try to visit in case you need to get more information and more details about the different topics that we are discussing throughout the course.